let it record. I will have some water and be back. Okay. So IP address, it's a logical address. IP address is logical address. Next. Also, we can. This statement is little sensitive, guys. Again, I'm telling, when you use a unique, means sometimes if you don't give a complete sentence, the meaning will changes, right? Unique address is MAC address. Uniquely identify a device in network is IP address. So if you can able to tell full sentence, no problem. If you cannot able to say full sentence, try to avoid this part. Okay, IP address is a logical address. That's it. Okay. In a network, we have multiple computers. If computers want to communicate each other, devices want to communicate each other, we need a logical topology, that is IP addressing. So logically addressing, address is important, right? So I want to write a letter to someone. So how to write a letter? To address is important. I want to send an email. I want to send an email. Mail address is important. Like in a network, we want to communicate each other. So compulsory IP address is very important. Without IP address, you cannot able to communicate. Without IP address, you can't able to communicate. So that is first. In IP address, we have IPv4, two versions currently available in the market. That is IP version 4, IP version 6. IP addresses depends upon your network. You will assign what IP address you want to assign. But small differences are there. We'll discuss about the small differences. It is a 32-bit. It's a 128-bit in a binary. So IPv4 is a 32-bit and IPv6 is 128. Guys, that's the difference. Okay, a lot of people by hurry, they will tell IP address IPv4 is 32-bit and immediately they get a 64-bit in mind. So be careful. IPv6 is a 128-bit. It represented in a decimal format. This is hexa format, hexadecimal format or hexa format. Actually, we should say hexadecimal format. This is, I said, hexa format. Hexadecimal format or a hexa format. So this is two things: 32-bit, 128-bit decimal format, and hexadecimal format. These two things. Okay. Okay. So here it is: 2 to the power of 32. A number of IP addresses you will get it. So total number of IP addresses are 2 to the power of 32. It is almost 4.3. So 4.43. I think 1. Sir. What I'm typing, 4.3 billion IP addresses. You will get it. Okay, so we can calculate if you want it also. You can calculate. So go to the calculator. So you can try. So 2 to the power of 32. Like this is 2 to the power of. We have to go to. So 2 to the power of 32 4.294 like that it is coming. It is means 4.3 billion IP addresses. 1 billion means 100 crores. 1 billion crores. Okay, 100 crores. Yeah, you know that one, but sometimes that is also one question. Okay, so 2 to the power of 128 number of IP addresses, right? So 2 to the power of 128, 4.3 billions of IP address. Exactly say, no, 1 second, 3.4 into 10 to the power of 38. Meaning is 4.3 billion IP addresses, you will get it. So a lot of IP addresses you will get it. Billions of IP addresses you will get it. Okay. So this is the two basic points. Okay. So one is 32-bit, another is 128-bit. So it is a 4.3 billion IP addresses, 3.4 billion IP addresses. Another one is it's a decimal format. It is a hexadecimal format. I'm not going to tell any again. Last time I told what is binary number, hexa kind of stuff. I'm not going now that one because it will take a lot of time. Already I'm killing a lot of time. Okay. So this one format. So example of IPv4 how it is look like is like 192.168. So 1.10. So just an example how IPv4 is look like. Okay. IPv6 example. So you can write in so many different type of IP addresses is there. So I will put a different ways like a hexadecimal, right? So A to F will be there. Just for fun, like to show you how many digits are there like that. So when you see like this, okay, how many hexadecimals also there also very important, right? So when it is come to the hexadecimal, guys, look at here. It is 128 bit. 128 in a binary. Hexa means 4 binaries. One hexadecimal is equal to 4 binary. 4 binary. So it is divided by 4. So it is 32 hexadecimal number. 32 hexadecimal. So the one IPv6 address is 32 hexadecimal number. 32 hexadecimal. So what is by 4? If you take one hexadecimal number, one single digit hexadecimal number is equivalent to 4 binary bits. So one hexa is equal to 4 binary. For bit space. So obviously we'll get 128 by 32 hexadecimal. It is look like this one. Next, here it is Unicast is there, MultiCast is there, Anycast is there. So that is also you can type Unicast, MultiCast, okay, broadcast. Here also Unicast, but in Unicast also different type of Unicast is there. MultiCast, broadcast. So Anycast. Unicast. Okay, like this kind of stuff. Okay, so we have a public IP address, private IP address. Okay, so in a public IP address, usually here it is, we call it as a global unicast address. Okay, global unicast address is a public IP address. Private IP is there. There is also some private IP address is there. So that is we don't discuss that one here. Okay. So in generally, every PC has their own IP address. Every PC in IPv6, every PC has a own IP address. Every device has own IP address. So that type of IP address is link local. Okay, guys, remember this is also I'm covering IPv6. That is called a link local. So link local range is FE80 : something. Okay, so the starting is FE80. When you see FE80 in the starting, like a FE80 : kind of stuff, that is a link local. It is a purely private IPv6 link local. Okay, link local, it is only in LAN communication, only works, only valid in a LAN communication. So no WAN communication, no global communication, only in a LAN, or we can say local only, local network, intranet only, or any word you can use, internet only. Okay, so in link local, it's we can use in communication purpose. Okay, link local IP address. You can anything you can check it. Okay. Next, local host or a loopback IP address is 127.0.0.1. Okay, what is a local host IP address? So every PC itself is a local host. For example, my PC has a name, but my PC name and your PC name and someone's PC name are different. Like mine is PC1, PC2, PC3, PC4. Like 4 PCs are there. Okay, PC1, PC2, PC3, PC4. So every PC has their own name, but also every PC has a common name for itself called a local host. Local host. And every PC has a unique address, like a IP address is there for communicating. But every PC has itself, there's an IP address for communicating itself. Communicating itself. That IP address is 127.0.0.7. It is a so it is. So here it is. In IPv6, the link local IP address is : 1. So even if you want to try, like you can say like a so first of all is like I want to ping my local host. So you're getting : 1. It means because of IPv6 is enabled, so I'm getting reply from : 1. If I disable IPv6, so I will get a reply from 127.0.0.1 only. Okay, so I'm pinging myself only, pinging myself. Okay, that is called a local host. Okay, you can use an IP address. For example, I install a web services in my physical machine. Now I want to access that web server from my PC only. From my PC only means web service in my PC, access from my PC only. So you can use your localhost address or a localhost name also. So that is your host. Okay. This is reserved for certain purpose, but same thing is represented like this. The IPv6. IPv6. Of course, there is a APIPA address is there. APIPA is not equivalent. It is okay. In IPv6, every device has its own IP address. Okay, irrespective of depending on anything. Okay, next. We need a DHCP, self-assigning kind of stuff. IPv6 don't require any DHCP kind of stuff because it contains its own IP address. Okay, I'm getting full body pains still. Okay, so this small things about your IPv6 and IPv4, guys. Again, 32-bit, 128-bit, 4.3 billion IP addresses, 3.4 billion IP addresses. Okay. Next, decimal format. IP addresses are in a decimal format, hexadecimal format. Unicast, multicast, broadcast, unicast, multicast, anycast. We have a public addresses for communicating through global network, through internet. Here we use a global unicast address. So that is like a, people say like a /2. Okay, global unicast address to represent that is a /2. /2 represent is, see, here it is. The starting 4 addresses I'm writing. Okay, so starting 4 addresses I'm writing here, like look at this one. 200 starting. Okay, the first 4. Okay, and 3FF. 3FFF. This is the total range of your global unicast address. This is the range. Okay, the /2 represent that one only. And of course, there is a few more things. NAT and PAT not required because we have a large number of IP addresses from IPv6. Network address translations, port address translations not required. That too, each and every PC having a unique IP address, you know, that is called a link local IP address. Every PC has its own IP address and it is unique IP address, that is called a link local IP address. Unique. Okay, so it is based on MAC of device. So it depends upon MAC address, you will get this one. So starting is FE80, link local IP address. So it works only within the local network only. But global communication, you should use multicast. And of course, guys, global unicast. Of course, guys, link local and global unicast, both are told. But you have to find multicast addressing, okay, local address like that. Local IP address is different. You don't require NAT/PAT kind of configurations because of we have large number of IP addresses. Okay, that is one more thing. Okay, highly available networks. Okay, so every device, everything we can able to use it. Okay, guys, I'm going with the IPv4 only again. So again, how many bits? 32 bit. So 2 to the power of 32. It is 4.3 billion IP addresses we are getting, right? So 4.3 billion IP addresses we are getting. So it is in a decimal format. So, okay. So IP addresses are starts with 0. Okay, I didn't tell this one now. These IP addresses are divided into 4 parts. Okay, and each part is having a dot. Okay, so it is divided into into 4 parts. 32-bit is divided into 4 parts. Okay, so each part is 8 bits. Each part is 8 bits, called as octet. Octet means 8 bits. Octet means octet. Okay, so this is called a dot. This is called a dot. So there is a dot. So the first part, okay, the first part is first octet. Okay, same as second part is second octet. So like this. First octet. First one is the first octet. Okay, it is become very big one. That's why I am removing all these things. Second one is second octet dot. Some people say point. So don't use a point kind of stuff. Dot. For octet. That is a correct word or a correct thing to spell. So first octet dot, second octet, third octet, fourth octet. Okay. Each one is 8. So it means 8 bit, 8 bit, 8 bit, 8 bit. So totally 32 bit. Okay. So this is each part is a octet. Now for some people use this kind of notation w, x, y, z. In certain textbooks, videos, you may see in this kind of stuff like a w, x, y, z. So guys, don't worry, both are same. This is the standard, like what I learn, the way I learn. So from my textbook, my source, my notes, that is first octet, second octet, third octet. In some places, some people, for easy to understand, they use a w.x.y.z. Like you can say, Madhu sir, like use x.y.z, because the material, like the way is easy to convey the message with the x.y.z. Okay, so w.x.y.z. For me, it is first octet. I always remember like that only, first octet, second octet, third octet. So it is no difference between those things. Okay, you know, some people will worry like, sir, you said first octet, second octet, sir said w.x.y.z. Both are different IP address kind of stuff. No, both are same only. So the way to understand is different. Okay, the first one is first octet, second one is second octet, third one is third octet, fourth one is fourth octet. Or first, like for our understanding, okay, which one is w, this is x, it's y, like that. So for a division. Okay. Next, there is a question called why IP address. Okay, so it is like a start with a 0.0.0.0 in a decimal format. If you write this same thing in a binary format, it is look like this one. First octet, second octet, third octet, fourth octet. Same goes. Next one will come like this. It is a very simple copy paste. This is the binary equivalent. Okay, and I'm not writing the second part, so then try to understand. So it is going on like this only. Okay, so it keep going like this, and you can reach up to 254. So like this, it keep going, guys. This is just a revision session, not a full complete IP classes. So it keep on going. Okay. So like the next one is become 0.0.1.0. Okay, 0.0.1.1. Like this, it will go. Okay. Finally, it reaches 255, 255, 255, 255. You know what is the meaning of this one is? 111.111.111.111. So 1, 2, 3, 4. Okay. So this is finally. So your IP addresses start with 0.0.0.0 and 1, 2, 3. It will increase 0.0.0.1, 0.0.2. It keep going and finally we reach the last one is 255.255.255. Okay. So totally the IP addresses from this to this. Total IP addresses from 0.0.0.0 to 255.255.255.255. This is the total range of a IP address, and this is the 4.3 billion IP addresses you will get it. Okay, so we divide 4.3 we divide IP address total range into classes. Totally 5 classes. Divided into totally 5 classes. Class A, Class B, Class C, Class D, Class E. Okay. There is a binary kind of stuff. Number is also there. Okay, I will go. So what will happen maximum? 1 second. Okay. So this is the binary number. So start with the 0. Yeah, I forget to see like this. 5 classes. Okay. To recognize. Sorry, I forget to say this point. Recognize the class of IP address. Okay. So it is based on first octet of IP address. Okay. Based on a first octet. Okay, range. Based on the first octet. Look at the first octet, then you will understand which class your belongs to it. To recognize class of that IP address, which class your belongs to, class A, class B, class C. So you have to look at the first octet of your IP address. For example, this is the first octet. Irrespective of what octets you are using, look at the first octet only. The range of, but the range that base bit in which range it is there, we can able to recognize. Okay. Same thing it is here writing. I'm writing a 1 octet, first octet range only I'm writing. Okay. So the first one is 0 to 127. So if you check with a certain textbooks, it shows 1 to 126. Both are right answer, guys. There is a condition that is 0.0.0. Okay, we don't use it. Okay, this kind of IP address, okay, not reserved for a certain services. 127.0.0.1 is for a loop back or a local host. It is a reserved for a loop back or a local host. Anyway, this is also we are not using, and we are also not using this kind of stuff. That's why. So we use from 1 to 127 only, but complete range is 1 to 120. Sorry, 0 to 127 only. Okay, so this is a 128 to 191. Okay. Again, I will ask no problem. So 100 000 means 110 1. Yeah, that is we don't have a time to discuss how I can able to convert and all. So how we to so that's the problem. 24 no 223. I'm writing a next numbers only, so it's a very simple number ranges only. Okay. So 224 to 239. So next is 240. 1 second. 240 to 255. Okay, guys. So this is the complete range. So again, take this range. Okay, yeah, we have to write here. This is R&D. R&D. We don't use this one also. We don't use this one. This is a multicast address. These first three are a unicast address. These are a unicast addresses. This is a multicast address. We use class A, class B, class C ranges only. We use class A, class B, class C ranges only. Again, I am removing this part. Class A 0 to 127, class B 128 to 191, class C 224 to 192 to 223, class D 224 to 239. So these are the classes in the networking. So compulsory, guys, whether you by heart or remember, whatever you do, you must do it. Okay. Next time writing API addresses are not a simple one. It is a very big one. Compulsory, you should recognize. Compulsory, you should know how to recognize the which class of network you are using. For example, 172.16.0.11. This is a which class it is?
Class B.
B. Okay. 110, 10, 100, 240. Which class it is?
Class
Class
A.
A.
Class A. Because of you have to look at only first octet. First octet only. Each octet maximum range is 255. Each octet maximum range is 255. So that's the point I not written. So here it is. The octet range is 0 to 255. Okay. So the octet is from either 0, 1, 2, 3 up to maximum 255 only, not more than 255. Okay. So like that we can able to recognize based on the first octet, we can able to recognize which class set of it is. Okay, very good, guys. And why it is called as a logical addressing? So why we call this one as a logical addressing, guys? So why we divide? That is another question. Is why we require to divide? That is another question. So look at here. Always remember. Okay. Same network means meaning is network portion same. By default, network portion same. Network portion is same. Network portion is same. So devices communicate. Okay. So the same thing is like I have a PC1 or PCA, PCB. Both are having an IP address. Both are having IP address. For example, network 1, host 1. This is having a network 1, host 2. Both can communicate each other. For example, this is a network 1, host 1. This is network 2, host 1. They won't communicate each other. Network 1. Network portion means network 1 means the network portion is same or different. This also won't communicate. This will okay. This is no. This is conflict. Conflict. This conflict. PCA, PCB, PCC. Okay. This is okay. Okay means works. So if you have a two PCs, there are having an IP address. First, you have to check the network portion of the IP address and host portion of the IP address. Make sure network portion must be same and host portion is different. Okay. So the statement is like this: network portion must be same. So the meaning is it is in a same network. Both are in the same network or not means network portion must be same. Both are in the same network or not. How to get it? You have to check it. Network portion must be same. Host portion is different. Different means different type of host portions. Either one difference in the host portion is also okay. Okay. So there is a little confusion in our host portions are there. So that's the host portions we'll see. Make sure host portion entirely should not be same. Okay. Host portion entirely should not be same. It means one difference must be there. Okay. So that no problem. So I will tell you that one if you are not getting that point. Okay. So what is this? So here it is. For example, okay, 190, 182, 17, 23, 45. This is a PCA IP address. Now I have a PCB. One 92. Once so 29, 34, 23, 44. Okay. So look at here. Whether these PCA can communicate PCB or not, only we can understand by ranges only. 182 means it's a class B. Class B. In a class B, first two portions are network portions. First two portions are network portions. First portion of PCA in PCB, same, good. Next portion, not same. Next portion, not same. Okay, so that is not good. Not good, it won't work. 17, sir, 29, not good. So same thing, it's like now can you able to tell is this PCA PCB can able to communicate each other? PCA PCB can able to communicate each other? Look at which class it is. It is a class A. The class A first portion is network portion. Only verify the first portion first. 12, 12. So both are same network. Then this is different. Okay, it's okay. Whatever the difference in the host portion is acceptable difference. Acceptable. Okay, which is okay. Now you can see first portion is same, next portion is same, but there is a difference here. There is a difference is there. So what I'm going to do is I will put a 29 here. Okay. So now you can see first portion same, second portion same, third portion is also same. It is a class C network. Class C network. So first three are network portions. So you have to look at the first three are network portions, and last portion is different. So this is the host portion. It's like this. So guys, host portion can be differs in one part or all parts, both acceptable. Okay, either in a one part is different or all parts are different. See, it is here. It is both are same. Class B. This is host. This is host. Both are same. It is different here. But here, if you look at here, these both are same. It is differ here, and it is differ here also. Here it is only this point. So at least one difference must be there. Okay. So first three portions are same, or like that. It can able to check it. So class A first portion, class B first two portions, class C first three portions. You must check it. So whether the devices can able to communicate each other. By mistake, you are done like that. Okay. So by mistake, you are configured like this. This is 19. This is 29. What to do? Change it. Change it. You have to plan properly. That's okay. Also, I'm giving default subnet mask. This is the default subnet mask of a class. So 255.255.255.0. So where is the N? There is a default subnet mask. Okay. So the default subnet mask is the 1 second. Subnet mask divide your IP into network and host portions. Okay. Subnet mask used to recognize what is your network ID. What is your network ID? Okay. Understand, guys? So how to divide is based on a ANDing operation. How to divide based on a ANDing operation. Again, it will take a lot of time to explain that one, so I'm not doing that one. Okay. Advantages and disadvantages of IP address, why we need to go for all like this. Yeah, one point is there. That's I will tell and put it. Okay, so 8 means host portion. Host portion. Here it is. I'm calculating host portion. Here it is. Number of hosts. Host means devices you're able to connect it. Okay. Number of hosts per network. That is the value I'm try to put it here. So 2 to the power of number of host bits. H is a 1 octet. 1 octet means 8. Okay. And minus 2 is also there. So it is a 256 minus 2 is a 254. It means if you have a 100 computers, 10 computers, or maybe 200 computers, you can use class C range. You can use class C range. Next, to the power of 16. What is why it is 16? So because of two H's are there. Each H is 8 bit. We'll get it. Okay. Class B. Yeah, this is little bit difficult. ID.
क्या हो गया भाई?
Hi, bro.
Hi.
Guys, can you able to hear now?
Yes, sir.
Yes, sir.
My internet is disconnected successfully. Okay. So how many are there? Only 4 or 5 members only. 5 members. So what to do? Okay, I will finish up this one and I will put a one very good message. I just, even though I am very tired, I am not able to speak. I conduct a class now. That is my problem. It is. Yeah, this is a disturbances. Okay, guys, I don't know how much you listen also. When it is disconnected also, I don't know. Okay, so class A, class B, class C, I done a -2. Why -2? So there is a network ID and there is a broadcast ID. So entire one single complete network, The starting one is network ID, the last one is broadcast ID. Okay, network ID is used to recognize what network you are belongs to it. Okay, broadcast ID is to broadcast the packets within the network. So we don't use network ID and broadcast ID for communication purpose. For communication means for assigning, we don't assign network ID and broadcast ID in okay, that can broadcast ID to devices. Okay, so that is why we are doing -2. That's why we are doing -2. That's it. The last two parts I will tell. Then I will finish up. Okay. Thing is, guys, there is another division is there, private IP address. Okay, private IP address. What is the private IP address? Okay, so this is the range of private IP address. RCA private IP address range is 10.0.0.0. Of course, you can put a 1 also, no problem. Okay, so 10.255.255.255. Okay, 172.16.0.0, 31.255.255. 192.168.0.0, 192.168. So 255.255. So this is class A, class B private IP addresses. Guys, what is the private IP address? Is what is this private IP? Okay, this is a important point. We'll see. So this is my network. I feel very bored because I expecting 14 out of 14, 10 people also not there here. I will take other day also, no problem for me. Okay, guys, look at this is my LAN network. In my LAN network, I have a computers. Okay, so to communicate in the LAN network, so you need a private IP address. If you put whatever the IP address, you can able to communicate private or public range. But better is private IP address. The private IP addresses won't forward to public. Okay, so the private IP will be in the local network. So in outside communication, you communicate with the public IP address only. Public IP address only. If you see, so if I type what is my IP address, so this is my IP address. This is my private IP address. What is this? Link local IP address. Okay, IPv6. Whatever it is my IPv4 private IP address range 192.168. It means it is a private IP address range only. Okay, so I am in a private range, but I am accessing internet, right? So I'm accessing outside through the internet. So because of certain technologies we use, NAT and PAT technologies we are using. Okay, so this is also like a private or local. What happened? That is working. Okay, private or a local it is. This is public, internet, public, okay, or a global. Okay, to communicate outside, we need a public IP address. To communicate inside, private IP address is required. So like that, we can save a lot of IP addresses by utilizing private IP address, public IP address. This is the range of private IP address. There is an explanation of private IP and public IP is there. So no, I am not able to because people are not there. So it is waste of my time again. Explanation. NAT means network address translation. Using a NAT and PAT, we can able to communicate from inside to outside. Network address translation, port address translation. Port address translation, network address translation, port address translation. NAT is it is also called as NAT overload. NAT overload, network address translation, port address translation. What is network address translation? Actually, it maps your local or a private address to public, global, public, or outside public IP address. Okay, so it will translates that kind of stuff. I put a why? Because of one local private IP to one public IP address. It is NAT. In a NAT, there is a two type of NATs are there. One is static NAT. Static NAT is one private IP address is translated into one public IP address. Okay, so next one is dynamic NAT. Multiple private means inside IP address to
public.
Yeah, you want a break? No, I don't want to give break, and I will close this session today because no one is there, very less people, and you are also you came, but you're waiting for a long time. Okay, if I take up to 7 o'clock like that again, why you and me suffer? That's why I just given some statements. I will close. Okay, relax and sit. Don't worry. I don't ask any. Multiple private to multiple public. This is like this, but port address translation is different. It is okay, multiple, okay, or it is like a all, multiple or a all private IP addresses to one public IP address. So here it's a dynamic. We can give an example for understanding. Okay, for example, I have a 10 private, I public. The extension of dynamic is port address translation. Okay, so technique is different. Dynamic NAT, PAT technique is different, but both are same. So this is about a network address translations. Of course, ACL is also there. ACL is also there. Okay, address access control list, allow the network kind of stuff, but at least understand the NAT, network address translation. Yeah, last one is APIPA, automatic private IP address. Automatic. I will close it, guys. Okay. People will be there because a lot of people 254 0.0 to 169.254 255 255. So this is the APIPA range, automatic private IP address. When you see this IP address, it meaning is error. Meaning is error. So when you are not able to, your means when device not able to get IP address from DHCP server, okay, assign a IP address to itself. Okay, so that is in range of 169.254. In range is better. In range of like this, called automatic private IP address. Okay, it is an error. So what to do? Okay, check DHCP server. DHCP server. So first troubleshoot the DHCP server. Problem not solved. ipconfig/release ipconfig. Okay. So use these commands to solve the problem. ACL is there, ACL part is there, and no, that's ACL part is there. Access control list is there. It is also same thing like a firewall, same as firewall, and also used in firewall configuration. It allow or deny a network or IP address, a IP address, network or IP address or a service or a protocol port number. Hello, Adreno protocol, port number, services. Okay. Okay. Inside to outside or outside to inside communication. Controls inside to outside, outside to inside communication. Of course, there is a standard access list, extended access list, named access list, numbered access list is there, but I'm not going thing, guys. Access control list, same as a firewall. Allow or deny a network. Network means logical network, IP network, or an IP address, or a service, or a protocol, or a port number. You can allow or deny inside to outside or outside to inside. Okay, it filters the traffic also. Okay, so that is ACL. Okay, ACL, APIPA, NAT, private IP address ranges. Okay, guys. Class A, Class B, Class C, Class D. Ranges are very important, guys. Ranges. NAT is also very important. Okay. Go through once questions. Okay, here there. So IPv4, IPv6. Find out the differences. So this is about your IP address. That's it for today, guys. Even my internet is also not connecting properly, but thanks for be there till now, at least last. Okay. Any questions? Anything? I know you are already exhausted.